Okay, hello everyone. Today we're going to be looking at externalities and government intervention. Before you've done this, you may want to have looked at externalities as well. That will help you. I'm going to start off by looking at the handouts. This handout is on SharePoint and will be linked with this video as well, and you will have had it in class if you're in 6B. So first of all, we're going to look at the need for government intervention. And these two diagrams here will show us the need for it. Here on our left-hand side, we have a positive externality of consumption, and on the right-hand side, we have a negative externality of production. And the problem with each of these two diagrams is that we are not achieving our full triangle of social surplus. And what we want to achieve is, in this diagram here, we want to get all of that nice big triangle of social surplus. Unfortunately, we only produce this amount of the good here, Q1, so that's the free market equilibrium. On the right hand side, we would have been best to have got to that amount. That's our maximum amount of social surplus. However, we are producing beyond that equilibrium, our free market equilibrium being there. That is overproduction. And in each of those, we get this welfare, potential welfare, that's a welfare loss of XYZ, it points to the right, and this is a welfare gain, it points to the left, as you can see there. Sorry, I've just said that wrong. That's a welfare loss on that side, that's a potential welfare gain on the left hand side. So, problem, we've got underconsumption, Q star minus Q1, you can see that there. Over here we've got overproduction, Q1 minus Q star. And we've got that potential welfare gain of XYZ and that welfare loss of XYZ. So the solutions we're going to do for this, the whole idea is to gain our big green triangle of social surplus. Social surplus is simply our consumer surplus, there's consumer surplus up there, plus producer surplus down there. We're trying to get the whole of that triangle. The solutions to that on the left hand side here is to get more. You want to move this way toward Q star. On this side, these are limiting policies. You want to move towards Q star that way. You're limiting the quantity of electricity. That makes sense. We tried to increase the quantity of healthcare. We tried to limit the quantity of electricity. And by doing that, we move towards Q star, the socially optimal equilibrium. If some of that didn't make sense, go back to my video on externalities. Okay, negative externalities of production. How do we solve that problem? Well, we can put a tax on it. Now, you can do one of these two diagrams. I'm going to give you two diagrams and to show you how they both work. So, the first thing we could do is we could put a tax on a normal tax diagram. Now, the benefit to doing this is that you can show the elasticity, as you can see there on my elasticity diagram, on my demand curve there, and you can show the total amount of tax revenue that the government get, being that whole area there. So you could show that, and you could show that as the quantity falls, Q2 here is closer to Q star, the optimal equilibrium. You've reduced the production of electricity and therefore you have in some way solved market failure. However, you could also do it in a different way. You could do it on this diagram, and on this one I'm going to do something which I quite like doing actually. This is quite a nice way of doing it, and you could shift it halfway. So on this diagram, what I'm going to show you is if you shift your marginal private cost up, you are going to get halfway towards your optimal equilibrium. And by doing that, you then cut the welfare loss to that blue triangle there. It was XYZ, now it's gone to the blue triangle there. And you can see that there, MPC has shifted up, the welfare loss triangle is reduced or eliminated, and market failure is reduced or eliminated. If it were eliminated, I would have shifted my MPC all the way up to there, and I'd just call that M equals MPC plus tax. You could do that too. However, if you're in an essay, a long essay question, you might want to push it halfway. And then you can say cleverly at the end of your point, well, we need some other policies to get us further toward Q star, whether that be advertising or subsidies or something else. Okay, so that's our first policy. The tax should be the go-to policy, the thing that you should go to for everything. That's the first thing that I would probably think of. Positive effects, well, the producer, the person who's creating the problem, is paying. That means there's also government revenue, which could be used for other things. You could, if you're going on to talk about a subsidy for a substitute good like wind power, you could say that could be used for that as well. We said that there is an internalization. The externality is internalized. That means that the market itself is paying the right price for polluting. And again, market failure, the original aim, has been eliminated or reduced. This is often called a carbon tax, by the way, and these have been used quite successfully. Negative effects, however, you're going to have high prices for consumers. Big problem right now because electricity is so expensive in the UK, and people have been saying that we should take tax off. So this disproportionate impact on the poor is a huge issue. You might take away the profits from the firms. You could even show it on this diagram here, and your revenue now is only that amount there rather than this amount here. Now you've got less profit. If I've got less profit, I'm doing less innovation. Maybe we need innovation from these firms to get other clean forms of energy. The big one, though, is it's going to be inelastic, and therefore you're going to need a very significant tax to get yourself to Q star. Link back to the previous point, a significant tax has an even bigger impact on the poor, and that means we can't tax our way to a better world. It is one policy, but if you're going to just use taxes, you are going to bankrupt the poor, or you're just going to mean that they can't use electricity. Electricity is so important, therefore this is not the only policy you should use. We could also say that government failure is likely. We don't know the elasticity of the good. We don't know where Q star is. We don't know how much to reduce our electricity supply, and therefore Q star is not known. So that can always be said. The second thing we could do, because we can't just use tax, we could use regulation, we could use laws. And so I'll lead you to read those yourself, but there are all sorts of laws that have been put in place. There are some examples. And one that I will focus on here is in coal-fired power stations, you've got something called sulfur filters. And the sulfur is the bad part of the emissions. It creates acid rain, it creates lots of problems for the environment. And so what they did, they just said, right, you have to put a sulfur filter in your chimneys, and that cleans up the emissions. Now, the regulation reduces the value of the negative externality. The value of the negative externality is the vertical distance between those two things, MPC and MSC. Remember, MSC is simply the cost to the firm plus the cost to any third parties. This bit here is the cost to the third party. This bit here is the cost to the firm. So if we reduce the cost to the third party, logically what we should do is we should be moving MSC downwards. So we could say MSC plus regulation. What we're doing is moving our optimal equilibrium out to Q star 1, which essentially just means that it's okay to produce more electricity now. It's not damaging the environment as much. Therefore, our socially optimal equilibrium has shifted this way. Now, the amount of electricity which is being consumed in the market, that stays the same. That is still Q1. There's no difference there, but it's not as polluting, and therefore there is less overconsumption, and as a result, there is going to be less welfare loss, I suppose you'd say. So that's very good. Overproduction is reduced, as you can see there. The positive effects, therefore, are that it's targeted. I talked about sulfur filters in power stations. That's a very specific thing that targets the problem. It reduces the actual cause of the negative externality. Rather than being a bit of a stupid policy just by reducing electricity, if we need electricity, then we need to find out what type of electricity is causing this problem. It's not all electricity. It's coal-fired electricity, which is emitting sulfur. And it can be cheap if the technology is available. Sulfur filters were cheap and an easy way of doing it. Another really good example of this is CFCs, which were in fridges. They banned them, and we had some alternatives that we could use. It was cheap and it was very effective. The negative effects of the regulation, well, it's obviously going to be difficult to enforce. You have to go around to the power stations and check them. There's always going to be government failure. And if we don't have that technology, if we don't have cheap sulfur filters, or if we can't do it, if we don't have an alternative to CFCs, or we don't have an alternative to petrol cars or diesel cars, then it's going to be very expensive to do it. We can only ban cars, combustion engine cars, when we have a viable alternative, which is the electric car. And that has to be at the same price. So it all really depends on whether you have the technology to enable you to do it, either to ban it or to encourage firms to change the way they produce the good. The third and most intelligent of all of these schemes is something called the tradable permit scheme. It involves the government giving a legal right to pollute using permits. You can pollute if you have a permit. If you don't have a permit, you are not able to produce this good. You're not allowed to pollute. If you're making less pollution, you can sell your pollution permits to other firms. If you produce more pollution, then you're going to have to buy those from other firms or the government. And you can get away with not having to buy pollution permits if you innovate. So if you make yourself cleaner, fit a filter on your chimney or something like that, then you can therefore start to sell your permits to other firms and make profit to fund your innovation. So essentially, this is a tax on polluting firms and a subsidy to innovating firms with no real involvement from the government in terms of having to pay for it. And it creates an internal market for permits, which are traded between the companies. And it's very, very clever. It enables the government to raise revenue. It sells the permits to the firms, and then they sort it all out themselves by buying it to and from each other. Now, the really clever thing about all of this is that it does two things. For a polluting firm here, it shifts up your MPC. MPC is the private cost plus cost of buying permits. So the permits raise the cost for your polluting firm. However, for your innovating firm, they sell permits. They innovate because you assume they have more money. They are now able to develop new cleaner technology. Maybe they have developed a wind farm or something like that. And that shifts your MSC downwards to that line. And so that line is also going to be MSC plus innovation. And that innovation has come from the fact that those firms have been able to sell their permits. So you're seeing that the polluting firms are being disincentivized and the non-polluting firms are being incentivized, which is a really, really clever policy. As a result, you're going to get a new equilibrium here. That gives you Q star 1 equals Q2. And that's going to be P star 1. There we go. We get a new equilibrium here. This is a little bit difficult to understand. You've got your free market equilibrium. Let's rewrite that properly. You've got your free market equilibrium, which is now equal to your socially optimal equilibrium, which is really, really clever. The problem with all of this is that other than, okay, it gives you that definite cap, there's no cost to the government, and as we've said, the efficient firms innovate. But the problem with all of this is it's going to cost you a lot of money to try and work out who's polluting what. The regulator